Hey guys, in this video, I'm going to go over how to do the section 3 of the probability of assignment, and that has to do with permutations. You probably haven't done permutations before, and at first it seems super scary, like there's an exclamation point in this formula. Are they really excited about this formula, or does that exclamation point mean something? We're going to go over how to do it, what it stands for, and when we should use it, and once you know how to do permutations, they're not so bad. Okay, so first thing that I want to point out is this is just the notation for permutations. This is the actual formula. So just like when we were doing the probability of drawing a yellow marble, the notation for that looked like this. We're not doing any math with this or this. It's just the notation. Kind of like when they say x equals. This is just the notation. You're not doing any math with that. So this right here is the notation, and it actually kind of makes this problem a little bit easier. All right, so the permutations formula looks like this. You have n factorial, n minus r factorial. If you don't know what factorial means, don't worry. I'll explain it in just a sec. First, we're going to kind of go over when you might use this. We'll do it the hard way, and then we'll do it the easier way with permutations formula. All right, so a band has 7 new songs and wants to put 5 of them on a CD. How many possible arrangements could they produce? Remember, if they use the same songs but arrange them in a different order, we're going to count that as a different CD, a different arrangement of songs. So we could do this the hard way of kind of going through and being like, okay, 1, 2, 3, 4, 5. Look, we have an arrangement for a CD. 2, 3, 4, 5, 1. That's a different arrangement. 3, 4, 5, 1, 2. That's a different arrangement. And then just keep going down the list until we have exhausted all options. That would take a really long time, and after a while, it would be super confusing. So that would be the hard way. The easy way would be with permutations. So the notation right down here is going to make this formula a lot easier. The n stands for the total number of possibilities or choices, in this case 7. They have 7 songs to choose from. And then 5 would be the r, or the constraint. So they have 7 to choose from, but they can only choose 5 to put on that demo CD. Okay, so we're going to go ahead and use this notation to set up our formula. So we have n on the top, the total number of choices, which is 7, and we're going to do a factorial with that. I'll explain what that is in just a sec. And then on the bottom of our fraction, we're going to go ahead and take n minus r, which is just 7 minus 5 equals 2, and that goes on the bottom. Okay, so that's all that we've done so far, is just looking at our notation here and our formula. 7 goes on the top, n is the total number of choices, so that's 7. And at the bottom of our fraction, we took n minus r, which is 7 minus 5, and we got 2. Now we need to do a factorial with both of these. And factorial just means that you are multiplying one less number down to 1. Okay, so 7 times 6 times 5 times 4 times 3 times 2 times 1. And that's what factorial means. You're just multiplying down one step until you get to 1. Same thing with 2. We're going to multiply down until we get to 1. That's just 2 times 1. All right, now we're going to go ahead and type this into our calculator. 7 times 6 times 5 times 4 times 3 times 2 times 1. And we're going to get a big number at the top, and that's okay, 5,040. Bottom of our fraction, we have 2 times 1. Don't need a calculator to do that one. I know it's 2. All right, and then we're going to go ahead and simplify this fraction. So we have 2,520 possible arrangements. So it's a good thing that we didn't do this the hard way, because we would be working till the end of time trying to figure out how many possible combinations there were. So there's a total of 2,520 different possible arrangements they could make with those 7 songs. All right, we're going to go ahead and do one more together, just because permutations can be kind of scary. Pretend this isn't here. Okay. So I kind of wrote the formula right up over here for permutations. We have n factorial over n minus r factorial. We have 8 students in one class, and the teacher needs to make one seating arrangement. How many different possible seating arrangements could there be? So we're going to go ahead and we're going to use this notation to figure out our answer. We have 8 at the top, because that is the n, according to our notation right here, and we're going to do a factorial with that 8. So we're going to do 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. All right, now we need to take our n minus our r and do a factorial with that. So we have 8 minus 1 equals 7. So that goes at the bottom. And we're going to do a factorial with 7. So 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, if you've done math before, you might already know the answer, but we'll go ahead and go through it because we need to practice with factorials. So I'm just typing in 8 times 6 times 7 times 4 times 5 times 4 times 3 times 2 times 1. So everything that's on the top. And I get a really big number, 40,320. All right, now I'm going to do the same thing with 7. 7 times 6 times 5 times 4 times 3 times 2 times 1. And I'm going to get a really big number again, 5,040. All right, now I just need to simplify this fraction. And I get 8. 8 possible arrangements. All right, if you guys have any questions on factorials, feel free to ask. Just remember that the top number is going to be the n, which is the first number in your notation, factorial, divided by the n minus r, and a factorial with that answer. All right, and then it's just simplifying a fraction. See you later, guys.